Yesterday we discussing about the topic of Azeotropic mixture. Yesterday we discussing regarding the topic of Azeotropic mixture. So what do you mean by this Azeotropic mixture? Means it is a binary liquid mixture. It is a binary liquid mixture having same composition in liquid phase as well as in vapor phase. It is a binary liquid mixture It is a binary liquid mixture having same composition in a liquid phase as well as in vapor phase. Here I taken two components are present in this liquid mixture. Both components are present which state means liquid state. What is the specialty of azeotropic mixture means the composition in liquid phase and vapor phase both is going to be same. What is the composition of components in liquid phase? The same is the composition in vapor phase also. What is the mole fraction of A and B in liquid phase? The same is the mole fraction of A and B in vapor phase also. It is the specialty of what means azeotropic mixture. So what is azeotropic mixture means? The binary liquid mixture having same composition in liquid phase as well as in vapor phase is called as what means azeotropic mixture. Okay, so here one more thing we can say about what is the another unique feature of azeotropic mixture means okay, actually we take in here both different components. A is a different component and B is a different component, but only in azeotropic mixture, what is going to happen means at what temperature A is boiling, at the same temperature B also gets boiled. Okay, A and B, although these two are two different components, both are boiling at the same temperature. It is the one more unique feature of what means azeotropic mixture. The binary liquid mixture having same composition in a liquid phase and vapor phase and boils at a constant temperature. It is called as what means such a kind of mixture is called as what means azeotropic mixture. I should also said you azeotropic mixtures are formed by which kind of solutions means non-ideal solutions. Non-ideal solutions are going to form this azeotropic mixture. Non-ideal solutions are going to form this azeotropic mixture we can say. Next we can discuss one more thing here. Okay, this azeotropic mixtures are of two types is there. Azeotropic mixtures of two types is there. What are the two types of azeotropic mixtures means? One is minimum boiling point azeotropic mixture. Minimum boiling point azeotropic mixture, and the other one is maximum boiling point azeotropic mixture. Azeotropic mixtures is of two types is there. What are the two types of azeotropic mixtures we are having means minimum boiling point azeotropic mixture and maximum boiling point azeotropic mixture. So yesterday I given you some relationships of boiling point also. Okay, what do you mean by this boiling point means the temperature at which internal vapor pressure becomes equal to the external pressure or atmospheric pressure. That particular temperature we are calling as what means boiling points. Yesterday class I given you two important relationships in boiling point. What are the two important relationships I given you in boiling point means boiling point is directly proportional to external pressure. Boiling point is directly proportional to external pressure. External pressure can be also called as the atmospheric pressure. External pressure which can be also called as what means atmospheric pressure. And one more relationship I given you, boiling point is inversely proportional to vapor pressure. These are the two relationships we have discussed in the yesterday's class. Boiling point is directly proportional to external pressure. External pressure can be also called as atmospheric pressure, and one more relationship is boiling point is inversely proportional to vapor pressure. These are the two relationships we have discussed yesterday. So now I am discussing about the types of azeotropic mixtures. How many types of azeotropic mixtures we are having means two types of azeotropic mixtures we are having. One is minimum boiling point azeotropic mixture, other one is maximum boiling point azeotropic mixture. So which kind of non-ideal solutions will give us the minimum boiling point azeotropic mixture means, you can see here, which kind of non-ideal solutions will give us the minimum boiling point azeotropic mixture means, firstly we are discussing about the minimum boiling point azeotropic mixture. So once apply this relationship, students, boiling point to be minimum means vapor pressure should be maximum. Okay, second relationship you can apply here. Boiling point is inversely proportional to vapor pressure. Boiling point is minimum means vapor pressure is to be maximum. In which kind of non-ideal solutions we are getting highest vapor pressure means, once you can remember, non-ideal solution positive deviation and negative deviation. Positive deviation is what is the meaning? We are having more vapor pressure than expected. It is called which deviation? Positive deviation. Positive deviation means, you know that AB interactions are weaker. AB interactions are weaker means A is also easily converted to vapor state and B is also easily converted into vapor state. Hence we are getting very high vapor pressure. We are getting high vapor pressure. That is called as which deviation means positive deviation we are calling. And one more deviation is the negative deviation. In negative deviation, what we can say, AB interactions are stronger. If AB interactions are stronger, A will not be easily converted into vapor state, as well as B is also will not be converted easily into vapor state. Hence we are getting lesser vapor pressure. We are getting here what means lesser vapor pressure. So this is called as what means negative deviation, and this is called as what means positive deviation. Always remember that in positive deviation we are getting huge amount of vapor pressure. In negative deviation we are getting less amount of vapor pressure. Now we are discussing about here minimum boiling point azeotropic mixture. Minimum boiling point azeotropic mixture means, it is exhibited by, minimum boiling point azeotropic mixture is exhibited by non-ideal solutions. Boiling point to be minimum means vapor pressure to be maximum. Vapor pressure is to be maximum. That's why we say that minimum boiling point azeotropic mixtures are exhibited by non-ideal solutions. Non-ideal solutions showing positive deviation. Minimum boiling point azeotropic mixtures are exhibited by non-ideal solutions showing positive deviation. Here, why it is called as minimum boiling point mixture means when compared to the boiling point of components, mixture is having lesser boiling points. When compared to the boiling point of components, mixture is having lesser boiling point. Hence, we got the name minimum boiling point azeotropic mixture. When compared to the boiling point of its components, the mixture is having what means lesser boiling point, we can say. Boiling point of mixture is less than boiling point of mixture is less than the boiling point of its components. Hence, that's why it is called as what means minimum boiling point azeotropic mixture. We should take one example, then you can understand it very clearly. What is the example here for the best example we are having for minimum boiling point azeotropic mixture means ethanol water mixture. Ethanol water mixture containing ethanol water mixture. In the mixture of ethanol and water, how much percentage of ethanol is present means 95% by volume of ethanol is present. 95% by volume of what is present means ethanol is present. It is the best example you can say for the solution exhibiting minimum boiling point azeotropic mixture. Ethanol water mixture containing 95% by volume of what we can say means ethanol. Here you can see water boiling point how much means pure water boiling point 373 kelvins, and ethanol boiling point is 351.5 Kelvin. Pure water boiling point is 373 Kelvin and ethanol boiling point is 351.5 Kelvin. Whereas the azeotropic mixture means this ethanol water mixture. The azeotropic mixture boiling point is how much means 351 Kelvin. Mixture boiling point is how much? Means 351 Kelvin. Hence you can see clearly here the boiling point of the mixture is less than the boiling point of its components. Hence it is called as what means minimum boiling point. Azeotropic mixture we are calling. The boiling point of mixture is less than the boiling point of its components. Therefore it is called as the minimum boiling point azeotropic mixture. We can discuss one more thing. What is the next one type is maximum boiling point azeotropic mixture. Maximum boiling point azeotropic. So firstly, okay, maximum boiling point azeotropic mixture we shall discuss. Maximum boiling point azeotropic mixture. Maximum boiling point is to be maximum. Boiling point we have to get maximum means vapor pressure should be minimum. Boiling point is maximum means vapor pressure should be minimum. I already told you in which kind of non-ideal solutions vapor pressure very less you will get means in the non-ideal solution showing negative deviation. In the non-ideal solutions which are exhibiting negative deviation, non-ideal solutions which are exhibiting negative deviation, interactions are very stronger and the vapor pressure is very less. Vapor pressure is very less. So vapor pressure is lesser means boiling point will be maximum. Hence we can say that maximum boiling point azeotropic mixture is formed by non-ideal solution. Non-ideal solution which is showing negative deviation. Non-ideal solution which is showing which kind of deviation means negative deviation we can say. Non-ideal solution which is showing negative deviation, its boiling point what we are getting means maximum we are getting. Okay, next what are the examples we are having? Here why it is called as the maximum boiling point azeotropic mixture means here maximum boiling point why we are calling means here the boiling point of the mixture, is more than the boiling point of its components. The boiling point of the mixture is more than the boiling point of its components. Therefore, we given the name maximum boiling point azeotropic mixture. The boiling point of mixture is greater than that of the boiling point of its components. Okay, the best example what we can say for this maximum boiling point azeotropic mixture means we can take this example. Mixture containing 68% nitric acid and 32% water by mass. A mixture containing 68% nitric acid and 32% water by mass. If you take this azeotropic mixture which is containing 68% nitric acid and 32% water by mass, you can see here in this mixture nitric acid boiling point is the boiling point of nitric acid is 359 Kelvin, whereas the boiling point of water we know it is 373 Kelvin. Whereas the mixture boiling point is how much means boiling point of mixture is how much means 393 Kelvin. The boiling point of mixture is 393.5 Kelvin. Whereas you can see clearly here the boiling point of mixture is greater than the boiling point of its components. Hence we can call it as which kind of azeotropic mixture means maximum boiling point azeotropic mixture. We can call it as what means maximum boiling point azeotropic mixture. So this is the concept of azeotropic mixture, students. Very important for theory point of view examination. Okay, so many times they asked specifically asked the question as what is the example for minimum boiling point azeotropic mixture? What is the example for maximum boiling point azeotropic mixture? Okay, so many times they asked this question. In the solutions lesson, we know that we are going to get one essay question for 5 marks. In the essay question for 5 marks, 3 marks we are getting the problem from colligative property that we shall discuss from tomorrow's class. Okay, 3 marks question, one problem, one numerical problem. We are maximum they are giving from what means colligative properties. We are totally having 4 colligative properties in our syllabus. We shall start the discussion of colligative properties from tomorrow's class. From any of the colligative property, one numerical problem is going to be asked for how many marks means 3 marks. Okay, next. And remaining 2 marks, they are giving this type of twisted questions like read the example for minimum boiling point azeotropic mixture, example for maximum boiling point azeotropic mixture. Such type of questions they are asking. So that's why once we have to perfectly thoroughly in this topic. So azeotropic mixtures we are having of how many types means 2 types. Once again, what's the definition of azeotropic mixture means? It is a binary liquid mixture having same composition in a liquid phase as well as in which phase means vapor phase and boils at a constant temperature. Such a kind of mixture is called as what means azeotropic mixture. Although in azeotropic mixture we are having 2 different components, both the components are boiling at the same temperature. That's why we can say the components of azeotropic mixture, it is not at all possible to separate them, by using which technique means distillation technique. The components of azeotropic mixture, they cannot be separated by using which technique means distillation technique, because both the components are boiling at the same temperature. Yesterday's class I said to this point, both the components are boiling at the same temperature. We can't separate the components of azeotropic mixture by using distillation technique. Okay, and this azeotropic mixture is of how many types is there means 2 types is there. One is minimum boiling point, other one is maximum boiling point. Boiling point is to be minimum means vapor pressure is to be maximum. Boiling point is minimum means vapor pressure is to be maximum. In which kind of non-ideal solutions you are getting highest vapor pressure means non-ideal solutions exhibiting the positive deviation. So this minimum boiling point azeotropic mixture are formed by the non-ideal solution showing which deviation means positive deviation. And next we can say why it is called minimum boiling point means when compared to the boiling point of the components, mixture boiling point is lesser. Hence it is called as what means minimum boiling point azeotropic mixture. The best example for this one is ethanol water mixture containing 95% by volume of ethanol and 32% by volume of what? 95% by volume of ethanol and remaining 5% by volume of what means water we can say. And today next one is maximum boiling point azeotropic mixture. Maximum boiling point. Boiling point is to be maximum means vapor pressure is to be minimum. In which kind of non-ideal solutions you are getting very lesser boiling point means negative deviation. Less in negative non-ideal solutions showing negative deviation, vapor pressure is very lesser. Hence we can say maximum boiling point azeotropic mixtures are formed by non-ideal solutions which are exhibiting negative deviation. What is the example we can say for maximum boiling point azeotropic mixture means the azeotropic mixture which is containing 68% nitric acid and 32% water by mass. It is the best example we can say. Why it is called as maximum boiling point means when compared to the boiling point of its components, mixture boiling point is higher. What is the best example we are having for this category means the azeotropic mixture having 68% nitric acid and 32% water by mass. Nitric acid boiling point 359 Kelvin, water boiling point 373 Kelvin, whereas the mixture boiling point is 393.5 Kelvin. Hence this is about the minimum boiling point azeotropic mixture and maximum boiling point azeotropic mixture. Students, I have to discuss one more topic here. When I discussed about the Henry's law, I had not discussed with you regarding the applications of Henry's law. I want to discuss that thing also today. Applications of Henry's law. We completed this topic of azeotropic mixture. I want to continue the topic of applications of Henry's law. In the previous classes only, I explained you about Henry's law, but at that time I did not discuss with you regarding applications. So I want to end it here today. I want to take it today. So today we shall discuss about the applications of Henry's law also. Applications of Henry's law. What Henry's law says means, according to Henry's law, we know that the solubility of gas in liquid, is directly proportional to pressure of gas present above the surface of liquid. The solubility of gas in liquid is directly proportional to pressure of gas present above the surface of liquid. It is called as the Henry's law. You know the Henry's law formula also. What is the Henry's law formula? P is equal to Kh into X. P is equal to Kh into X. So what are the applications of Henry's law we are having? Is first one. So we know that cold drink bottles and soda water, they contains which gas in it, means carbon dioxide gas has been dissolved in it. So if you want to dissolve more amount of carbon dioxide gas, if you want to dissolve more larger amount of carbon dioxide gas, we can seal the bottles under high pressure. If you are sealing the bottles under high pressure, pressure is more, solubility is also more, okay, hence more amount of carbon dioxide gas will be dissolved in the soft drink bottles or soda water bottles. Okay, if you are sealing the bottle under low pressure, the amount of carbon dioxide gas dissolved in the soda water or cool drink water is also less. It is the first application we can say about the Henry's law. Okay, how much amount of carbon dioxide gas is dissolved in this soda water or cold drink water, means it is depending upon the pressure, with how much pressure you are sealing the bottle. If you are sealing the bottle with more pressure, more amount of gas will be soluble in it. If you are sealing the bottle with low pressure, less amount of gas will be soluble in it. Okay, this is about the first application, the solubility in the soda water bottles you can see. Regarding soda water bottles we can see. Okay, next we can say. Okay, next we shall discuss about the scuba divers. Scuba divers. Who are called as scuba divers means, okay, you can see in the, okay, some Discovery Channel, National Geographic Channel like this. Okay, so many persons are going deep into the ocean for study about the aquatic organisms and for study of aquatic life. Those, okay, the persons are going deep into the ocean. So those persons who are traveling deep into the sea or deep into the ocean, those persons are called as what means scuba divers we are calling. Those persons we are calling as what means scuba divers. These scuba divers, they use it to carry a compressed air cylinder on their back. This compressed air cylinder contains mainly nitrogen gas and oxygen gas. This compressed air cylinder which is carried by the scuba divers, they contain mainly nitrogen gas and oxygen gas. You can imagine here the person has gone deep into the sea. Deep into the sea means, okay, on the surface of the person, a huge quantity of water is present. Huge quantity of water is present means we can say the person now is under a high pressure region. The person is at high pressure region. When the pressure is high, the solubility of gases is also high. When the pressure is high, the solubility of gases is also high. So when the person is at the deep of the sea, due to high pressure, large amount of oxygen gas and more amount of nitrogen gas gets dissolved in his blood. In his blood, more amount of oxygen gas and more amount of nitrogen gas gets dissolved in his blood. Again, the person after completion of work at the deep of the sea, again when the person is coming back to the land, and then again when the person is coming back to the land, at the land means the pressure is less. Deep in the ocean means pressure is high. Again when the person has come back to the land where the pressure is less, okay, now the pressure is less means the solubility of gases is also less. Now, okay, what are the gases, what are the excess amount of gases which have been dissolved in the blood? Those gases try to come outside. Those gases try to come outside. There is no problem with oxygen gas. There is nothing problem with oxygen gas. The oxygen gas also dissolved in the blood that will be used for carrying the metabolic activities. The problem is with the nitrogen gas. The problem is with which gas means nitrogen gas. When the nitrogenous gas is coming out from the blood, okay, it is forming some bubbles. You know that whenever the gas is releasing outside, some bubbles are formed. Okay, the bubbles can block the capillaries. The bubbles can block the capillaries, or it may cause the capillaries to burst. Okay, that is a very serious health condition we have to say. That condition is called as what means bends we are calling. That condition we are calling as what means bends we are calling. So what do you mean by this bends means when the nitrogen gas is coming out from the blood, it is released out from the blood in the form of bubbles. That bubbles will block the capillaries. Okay, if the capillaries are blocked, there is no flowing of the blood. Okay, it is leading to the very much serious health condition. That is called as what means bends we have to call. What we should call means bends we are calling. So we can prevent the risk of the bends. Okay, I am not saying totally we can avoid the bends. We can prevent the risk caused by the bends. How we can prevent the risk caused by the bends means we can decrease the amount of risk caused by these bends. We are getting the bends mainly because of which gas means nitrogen gas. We are getting the mainly the bends because of which gas dissolved in the blood means nitrogen gas dissolved in the blood. So one thing what we can do means, what is the one thing the suggested basing upon some research later on, what the suggested means the compressed air cylinder which has been carried by the scuba divers, the compressed air cylinder which has been carried by the scuba divers can be diluted with which gas means helium gas, can be diluted with helium gas. Okay, instead of what we can do here means we can reduce the percentage of nitrogen, we can reduce the percentage of nitrogen, and instead of that nitrogen we can mix which gas means helium gas. What are the advantages of helium gas when compared to nitrogen gas means helium gas is very much less soluble in the blood. Helium gas is very much less soluble in the blood, and helium gas size is very less. So when it will come outside from the blood very easily without forming the bubbles. Without forming the bubbles, helium gas can come out from the blood very easily. So in this way we can prevent, we can slightly decrease the amount of risk caused by the Bend's disease by decreasing the percentage of nitrogen. Instead of nitrogen, we can mix with which gas means helium gas. We can mix with which gas means helium gas. Very important objective point. In order to prevent the, in order to reduce the risk of Bend's disease, which gas is used means preferably helium gas is used. What are the advantages of helium gas means? Helium gas is having very less size and it is very much less soluble in the blood. These are the advantages of helium gas, we can say. So understand, this is about the second application of Henry's law, we can say. Okay, second application of Henry's law mainly we can observe in the scuba divers. Okay, which persons are called as scuba divers means those persons who are traveling deep into the sea for study of aquatic organisms, they are called as the scuba divers. The scuba divers will carry one compressed air cylinder on their back which mainly contains nitrogen gas and oxygen gas, Okay, when the person is going deep into the sea, the deep in the sea is considered as the high pressure region. At that high pressure region, nitrogen gas gets dissolved in the blood in more quantity, oxygen gas also gets dissolved in the blood in more quantity. Again, the same person after completion of work there, when he is coming back to the land means low pressure region. Okay, low pressure region, what happens? Okay, what are the gases which are soluble in the blood at high pressure? That soluble gases. Now the pressure has become less means solubility also becomes less. So what are the gases which have been dissolved at high pressure? They are starting coming out from the blood. Especially when the nitrogen gas is coming out from the blood, it is forming some bubbles. That bubbles are blocking the capillaries. Okay, that condition we are calling what means bends. We are calling that condition we are calling what means bends. We can decrease the percentage of risk caused by the Bend's disease by what we can do for that purpose means we can reduce the percentage of nitrogen in compressed air cylinder and we can mix which gas means helium gas. The compressed air cylinder what we are carrying, it should be diluted with which gas means helium gas. If it is diluting with helium gas, what are the advantages of helium gas means helium gas is having small size. Helium gas will be released from the blood easily without forming much bubbles, we can say. So this is we can say about the second application of Henry's law. And third application we can say, in the lungs, in our body, in the lungs pressure is more. In the lungs when pressure is more oxygen gas, pressure is more means solubility is also more. More oxygen gas gets dissolved in the blood. Okay, that blood after dissolving the oxygen gas into it will move to the tissues. In the tissues, pressure is less. Pressure is less means the oxygen gas which has been dissolved in the blood, it is coming outside. Because the pressure is less. Okay, the oxygen gas which is coming outside, it will be used by the cells present in the tissues. It is one more application we can say about the Henry's law. In lungs, where the pressure is more oxygen gas gets dissolved in the blood. The blood which is containing the dissolved oxygen, it will move from lungs to the tissue. In the tissue, the pressure is less. Pressure is less means solubility of gas is less. Then in the tissue, since the pressure is less, Okay, some amount of gas which has been dissolved at high pressure, it is coming outside. Okay, it is coming outside. The gas which is coming outside, it will be absorbed by the cells present in the tissue and will be used by the cells present in the tissue. Okay, it is what we can say. Next we can say, last application, the persons who are climbing to the top of hill. The persons who are climbing to the top of the hills. The persons who are climbing to the top of the hills. Top of a hill means it is a low pressure region. Top of the hill, it is which type of region means low pressure region. So low pressure region means the solubility of oxygen. Outside pressure is less. Outside pressure is less means the solubility of gas in the blood is also less. The solubility of oxygen gas in the blood is also less. So the person is not getting sufficient amount of oxygen. The person is not getting sufficient amount of oxygen. If the person is not getting sufficient amount of oxygen, he cannot think properly and he will become very weak also. That condition is called as what means anoxia, we should call. That condition is called as what means anoxia. So this anoxia condition you can observe in those persons who are climbing to the top of a hill. Who are climbing to the top of a hill. Top of a hill means pressure is less. Pressure is less means solubility of oxygen gas in the blood is also less. So our body is not getting sufficient amount of oxygen required for carrying the metabolic activities. Hence the person, okay, in such a situation, the person will become very weak and he cannot think properly. This condition is called as what means anoxia we are calling. So all these things we can call it as what means applications of Henry's law. Applications of Henry's law, they basing upon simple point that pressure is more, solubility is also more. When the pressure is decreased, solubility is also decreased. Okay, when the pressure is decreased, what is the excess amount of gas? Okay, in a high pressure region, ಜಾಸ್ತಿ gas soluble ಆಗಿರುತ್ತೆ. When the pressure has been decreased, okay, so the solubility also what will happen is decreases. So what if the excess amount of gas is dissolved in the high pressure, it will be coming outside. It will be coming outside. Okay, so this is about today's class. We completed about the topic of solutions. So solutions. Okay, this chapter is having two parts actually. One part is solution and second part is colligative properties. By today's class, we completed up to the solutions part we completed. From next class onwards, we shall discuss about the second part of this lesson regarding colligative properties. We shall start our discussion. Okay, thank you very much.